So let's talk about conditional probability, the symbols, the meanings, all the things. So given events A and B, the probability of event B occurring, knowing that event A has already occurred. Come on, Gordon. Is called conditional probability. Now, the notation, how you're going to see that, the probability of B, and then you have that vertical up and down. So the probability of B given A. Now, again, this is so wordy and confusing when you look at the formulas, but I promise when we read them, I'm going to make this easier for you. So the formula to actually calculate this conditional probability. Now, let's start with the bottom. You know I like to do the bottom all the time, the total. So that's the probability, it's going to change on this one, of A, the second event. The top is the probability of A and B, which looks so crazy, okay? But I promise it's going to be simpler than what this looks like. So notice, and I don't get carried away with, oh, what's A, what's B? So I think about events, first, second. So the second event probability is going to be in the denominator. The top, the numerator, is the probability of both of those events occurring together. So let's just look at one. So of course we have to have numbers 1 through 20 is chosen at random. Find the probability. Okay, so first thing I see on number 1, we're talking about prime numbers. I swear we have listed the prime numbers a bazillion times. We're going to start listing them again. So 1 through 20, start giving them to me. What are the prime numbers? 2. Okay. So that's why you have the little room on the side there, of course. Now, so to do our probabilities. So now on that red list of numbers, I am looking for prime numbers and greater than 8. So out of the red numbers, of those red prime numbers, we did the prime parts, which ones are also greater than 8? So there's 4 of them. 4 out of 20 numbers. So that's the numerator. Okay, because you're going to have 2 fractions we're going to have, because remember your formula. I'm going to click it back a second. You have 2 probabilities. Remember, probability is a fraction. So you're going to have a fraction on the top, fraction on the bottom. I'm going to show you how to simplify it, but you're going to see a really shortcut here that happens. It's going to make it easy on you. I got to do the bottom now. The denominator is the probability the numbers are greater than 8. Well, there's still 20 total numbers. Now, I'm going to list them, but you could probably just count them or figure it out. So greater than 8, does that include 8? No. So that's going to be 9. Why does that look like a G? 9, 10, 11, all the way up to 20. So count them. How many numbers are greater than 8? 12. Now, you know I live for fraction work, but again, you're going to see a shortcut happen here. Watch this. When you divide 2 fractions, old school math, we multiply by the reciprocal. So I'm flipping the bottom one, which really what happens to the 20s. So you're going to start seeing that pattern, that shortcut. It's going to make your life really easy. I'm left with 4 over 12, but let's reduce 4 over 12. What's 4 over 12? 1/3. And you can do all the calculator work, obviously, all the fraction work in your calculators too, for sure. Okay, so here we go. We're thinking about our numbers. Multiple of 3. So let's list those. Again, I'm going to use the space over here on the side. So multiples of 3. 3 times 1. 3 times 2. 3 times 3. 3 times 4. 3 times 5. 3 times 6. Now I'm stopping at 3 times 7. Why am I stopping at 3 times 7? That's past 20, right? We can only go 1 through 20. So off those blue numbers, which ones are multiples of 3 and odd? 3 is, what else? 9. So 3 out of 20 is going to be our top fraction. Okay, bottom fraction. I know it's going to be out of 20. We're going to figure out odd. So 1 through 20, how many of them are odd? 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. How many? 10. Isn't it half of them? Half are odd, half are even. Now again, I'm going to do the fraction work. You can rock it in your calculator. 3 over 20 multiplied by the reciprocal. You can see the pattern. Those are going to cancel, and you just have the 3 and 10 left, which a lot of you will probably just skip all of this and just see the pattern and go straight to 3 over 10, which eventually I'm going to do that too. All right, let's do at most 15 and a perfect square. Okay, we're not going to reinvent the wheel, because didn't I already list all the perfect squares? Isn't that the numbers? Oh no, we have not, sorry, we did prime. We didn't do perfect squares. I can list perfect squares. I'm going to do it in yellow just so it's a different color, but I know they don't, of course, appear the best, but I think you got it. Perfect squares: 1 squared, 2 squared, 3 squared, 4 squared. I'm stopping at 5, because what's 5 squared? Which is over 20. Okay, so at most 15 and a perfect square. So you can't go over 15, and it has to be a perfect square. How many of them are on the list? 3. So 3 out of 20 is our top fraction. Now, how many total perfect squares are there? 4. So 4 out of 20 is the bottom fraction. And shortcut, what are you going to end up with? 3/4. I mean, to me, this is like easy but tricky all in the same one. All right, let's look at 4. So 7 and no more than 12. So think about the numbers 1 through 20. I'm like, man, that's already wordy. 7 and no more than 12. Well, if I list out the numbers 1 through 12, I mean, how many of them are 7s? 1. Now, let's talk about the no more than 12. How many numbers are no more than 12? So what does that really mean, no more than 12? Is that 12 and under or 12 and over? 12 and under. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many numbers is that? 12. So shortcut, final answer, 1 over 12. Woo! Tricky stuff, tricky stuff. Now, I almost kind of like the next ones better because they're giving you some marbles. We don't have to list out like primes and perfect squares. There's a spinner. Like, I think it gets a little easier here. So that contains 8 red, 2 blue, 4 yellow, 6 white. So first off, we need the total. How many total marbles do you have? 20. So I'm just making a little note here. Okay. Now remember, we're going to have 2 fractions divided. Now, the first fraction, probability. I know it's over 20. Red and not blue. That's even weird to say. Red and not blue. I mean, so really we're talking about the red marbles. So how many red ones are there? 8. Now, the bottom fraction. That's the probability, remember, of the second event. So how many marbles are not blue? 18. Okay. Oh, I forgot the 2 and the 20, sorry. Okay, shortcut. You're going to be left with 8 over 18, which will reduce down to, yeah. Okay, I'm going to set it up here. I know we don't love the yellow, but I'm going to go for it. Okay, yellow and not white. Well, again, that even sounds weird for me to say yellow and not white. Well, of course, it's not going to be white, it's yellow. How many yellows are in there? 4. Now, how many are not white? So, of course, the 20s are going to cancel. We have 4 over 14, which reduces down to 2 over 7. So I'd rather do these instead of writing out prime numbers and perfect squares. I know that gets a little obnoxious. So I think it gets a little easier. So look at the spinner. A lot of things on the spinner. First, let's count quick. I'll give you a second. How many total letters are on the spinner? 16. I'm just going to make a little note here. Okay. So, of course, my first fraction, set it up, shaded and a vowel. Oh, gosh. So how many shaded and vowels are on there? 3. There's A is shaded and a vowel. E is shaded and a vowel. What else? O is shaded and a vowel. Okay. Bottom fraction, vowels. Well, how many vowels are on there? 4. We know our shortcut, the 16s are going to cancel. We can go straight to our final answer, 3/4. All right, hopefully we have figured out what a consonant is. All right, consonant and unshaded. So how many consonants unshaded are there? 6. Good on the counting. Okay, now how many unshaded pieces are there? 7. There's 7 unshaded. All right, of course that's nice, 6/7. All right, and let's do a card. We got a card. Okay, so remember, the spinner was only for 7 and 8, not for the card problem here, 9. Cards chosen at random from a standard deck of cards. How many cards? Okay, all right, 52 got it. Find the probability that the card is an ace, given that it's a diamond. So I'm going to start with the first fraction, of course, over 52. So ace, diamond. So my first question is, how many aces and diamonds are in your deck? 1. There's 1 diamond ace in the deck. Okay, 52. Now, your second, remember, is the probability of the second event. What's the probability that it's a diamond? How many diamonds are in the deck? 13. We know the shortcut, the 52s cancel. We are left with 113. So wordy. It's so wordy. Love it, hate it, all the things. Okay. All right, let's read 10. A date in the month of September is chosen at random. Find the probability it is an even number given it's before the 20th. Okay, so even number, you have space on the left. I'm going to kind of do it over here on the right. Given it's an even number. So I'm thinking about, okay, even numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Now I think I'm going to stop because it says before September 20th. So can I count 20? No. Okay. All right. So we're ready to go here. So my first fraction. So first question, we also need to know how many days are in September? 30. There's 30 days in September. Now, how many even before September 20th numbers are over there? 9. Okay. I'm going to do the bottom fraction out of 30. So remember, that's the second event before the 20th. So now you're just asking yourself, how many total days are before the 20th? 19, 1 through 19. And of course, the 30s cancel, you got it, 9/19. All right, any questions on that guy? Home stretch. I think the first round was the worst. The rest isn't so bad. The probability of Jasmine studying for a test and getting an A, interesting, Jasmine, is 13 out of 16. If the probability that Jasmine studies for a test is 9 out of 10, find the probability she'll get an A on the test given she's studying. So they've already done the fraction work for you. We just have to decide, is it 13/16 on top or the bottom? Which fraction goes where? Well, remember, the top fraction is the one of the 2 events together. So the probability she studied and gets an A. What's the probability of both of them? 13/16. That key word there, and. And then obviously just, getting blah, 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 the 9 out of 10. Now this one, because you have those different denominators, I can't just shortcut it. I'm actually going to have to do the fraction work. Or you can do it in your calculator, of course. Multiply by the reciprocal. Okay. Now, because I'm rocking without a calculator up here, I'm going to reduce 10 and 16. 2 goes into both of those. 2 goes into their 5. The other one's 8. And then I can do 13 times 5 in my head. And we should all know 8 times 9. Not that you can't do the fraction work in your calculator, but you will have to do it. So again, I think 12's easy because they give you the probabilities. We just have to figure out which is top, which is bottom. Remember, and is on top. All right, car lot has both used and new cars. If 86% of the cars on the lot are new and 45% of the cars are new and have a sunroof, find the probability of choosing a car with a sunroof given that it's new. So what's the probability it's new and has a sunroof? 45%. And then obviously The probability for the bottom is going to be our 86%. Now, okay, peeps. I do not, on my graphing calculator, and you probably obviously don't either, have a percent key. So here's where I got to have a little number sense. I know 45% is the same as 0.45. So in my calculator, I'm going to do 0.45 divided by 0.86. All right, and this one, you know, it's decimals. I just gave it as a decimal. It's about 0.52, whatever you want to round to. Or if you want to get fancy, 52%. Hit it, Jonas.
You just heard 45 over 86.
You could, yeah. All right. I kind of like those where they give you the numbers and you just have to divide. I like these two because the numbers are in the Venn diagram. We just got to figure out what's what here. So a group of people were asked if they drink coffee or tea. The results are shown in the Venn diagram to the left. If one of the people surveyed is chosen at random, find the probability. Well, first, of course, do a little math for me. I need the total. You know, I need the total. So add all those numbers up. 50. Okay, so we need that. Now, of course, our conditional probability, we're dividing our two probabilities, so I'm getting my first fraction. We know it's out of 50. Now, I'm looking for the people that drink coffee and drink tea. How many drink coffee and tea? 12. So there's my top fraction, out of 50. The bottom is the probability of just the second event, the drinks tea. Well, how many total are in the tea circle? 4 and 12 together, so 16. So this one's nice because you got the 50s, those will cancel. We have 12 over 16, which we're going to simplify all the way down to 3/4. Perfect. All right. Now, same spiel. I'm going to set up my two fractions. I'm trying to write small and fit it in here. I know I'm over 50. So first, does not drink tea and drinks coffee. So how many people know tea, but they drink coffee? 24. 24. And then our probability of the second event, the 50. How many drink coffee? How many in the coffee circle total? 36. 24 and 12. Got it. So we're going to have 24 over 36, which reduces to 2 over 3. Good. Got it. Okay. Let's set up my fractions again. I know I'm over 50. Okay. I'm just going to keep on reading. Does not drink coffee and does not drink tea. So who doesn't drink coffee and tea? Who doesn't drink any of it? 10 of them. Okay, probability for the bottom, 50. Okay, we need to know how many does not drink tea. So nothing in the tea circle counts. How many is not in the tea circle? So the 24 and the 10 are not in the tea circle, so 34. We got to add the 24 and 10 together. Okay, so we got 10 over 34, which reduces down to about 5 over 17. Okay, any questions on that? All right, last one, and honestly, I think we probably should draw a Venn diagram for this one too to help the cause, okay? So of the 400 freshmen, well, I know everything's over 400, okay? At Westview High School, 92 are in band, and then we have kids in chorus. So, all right, let's just start getting this done here. So we're gonna have a band and a chorus circle. So let's just start with that. Okay, I'm gonna keep reading. Now, I always look for the overlap first. How many are in both band and chorus? 20. I always like to fill that one in first. Okay, I'm going to keep on figuring this out here. 92 students are in band. So I need a total of 92 in the band circle. So how many more do I need to add into it? 72. Got it. All right, 60 are in chorus. So I need a total of 60 in the chorus circle. So how many more do I need to add to it? 40, because you already have the 20. Now, obviously, there's some kids that haven't taken either band or chorus. They're not taking any of it. Because remember, there's 400 kids. This is not 400. So how many aren't taking anything? 268. Okay. All right. So here we go. So we know there's 4 my fractions. We know we're over 400 kids. My teeny tiny writing of fractions there. Now, how many are in chorus and band? 20 is in the overlap. There's the top fraction. Bottom one, the probability, I did click blue, come on, the probability you're in band. Well, how many total are in the band circle? Band, 92. So we're gonna have 20 over 92. I reduced it down earlier for you, you don't have to do it. It's 5 over 23. So I mean, I don't think this is awful, but you just have to obviously read carefully. I feel like I've said that every lesson so far. Okay, all right, let's set up my fractions. I know I'm over 400. Now I'm gonna actually read it. Not in band and in chorus. So you can't be in the band circle here, of course, but you're in chorus. 40 is what's left there. Okay, and then let's do the probability you're in chorus. I know we're over 400. So total chorus circle, I heard it, is how many? 60. So we know the 400s are going to cancel. So we have 40 over 60. 2 over 3. All right, final one, my friends. Let's set up the fractions. I know I'm over 400. Okay, in band, so looking at the band circle, and not in chorus. So how many do you have for that? Band circle, no chorus. 72. Got it. Okay, over 400. Okay, probability of the second event, no chorus. You cannot be in the chorus circle. So what are you going to have for the top? I feel like a lot. Because we're going to have the 72 and the 268, which adds up to, and I'm just going to put a note there. We did 72 plus 268 is how we got it. All right, so you're going to have 72, of course, over 340, which does reduce all the way down to 18 over 85.